Hi class, today's lesson will be angles created by parallel lines and a transversal. And a transversal is a funny name, but we'll talk about what it means. So today we're going to be talking about things that look like this. So here are two lines, and if they're parallel, we can do it where we put this extra set of arrows on here. I'm going to make mine solid arrows. So this these solid arrows means that they are parallel to each other. And then we have this third line that we call a transversal because it cuts across two or more lines. So we're going to talk about Euclid's fifth postulate. He came up with ideas on which he based geometry on. Euclid is a 4th century BC mathematician known as the father of geometry. He basically took all the geometry that other people had worked on in that time frame and really composed books. So when we study geometry, we mostly study what is called Euclidean geometry. And then we're going to talk about a postulate. A postulate is idea that we accept without any proof. Okay, as opposed to other things that we have in geometry we call theorems, which can be proved. Okay, so Euclid's fifth postulate says if two lines are drawn which intersect a third line in such a way that the sum of the inner angles is less than 180 degrees, the two lines inevitably must intersect each other on that side. If extended far enough. What does this mean? Well, basically what we can do is, let me grab my pointer and let me move this up a little bit. If I have, here are my two lines. And they hit a third line. Here's a third line. And I create these two angles. Angle 1 and angle 2. These are my inner angles. Well, since the measure of angle 1 plus the measure of angle 2 is less than 180 degrees, the two lines, well, that's pretty messy. The two lines will intersect. See, on the other side, these angles are bigger than 180, but together these are 180. Okay, on the next page there'll be a better diagram. So as you can see, here's a little bit of a better drawing. I have two lines, L and M, that are crossed over by the third line, line N. That's our transversal, and I have these inner angles, alpha and beta. And right now, you can tell that the measure of angle alpha plus a measure of angle beta is less than 180 degrees. So that means sooner or later, these guys will intersect. So the big question is, what if the sum of these two angles is equal to 180 degrees? Exactly. That's what we're going to work on today. So here's the situation I was talking about. Lines L and M are parallel. How do I know they're parallel? Because when I drew them, I put these little extra arrows on these lines to indicate they're parallel. I have my inner angles alpha and beta coming from line N, the transversal. So basically, this is what's going on. The sum of those two inner angles is equal to 180 degrees because line L is parallel to line M. This little symbol means parallel. Okay, so again, since the sum of those angles is equal to 180, that means L and M are parallel, and vice versa. If L and M are parallel, then the sum of those two angles is equal to 180. They go hand in hand. Parallel means the two lines never intersect. We use this double line symbol to show that they're parallel. If those sum of the two angles were less than 180 degrees, then the two lines would intersect. So let's talk about angle relationships between parallel lines and a transversal. So these two lines are parallel, and it's indicated they're parallel by these extra little arrows here. And I have this transversal. It's the line that cuts across these two other lines. And I have all these angles. I have 1, 2, 3, 4, 5, 6, 7, 8 at these 2 points of intersection, and get used to it because that's the way I usually label these angles. 1, 2, 3, 4 around the vertex, and 5, 6, 7, 8 around this other vertex in that order. So what does it mean to be corresponding angles? So a corresponding angle. Basically, corresponding means same location. So corresponding angles are angles that are in the same position relative to the transversal and the parallel lines. So right here, angle 1, here's the vertex. Angle 1 is the top right angle, and angle 5 is the top right angle. Angle 1 and angle 5 are corresponding angles. Angle 3 is the bottom left. Angle 7 is the bottom left. They are corresponding angles. They're in the same location when you look compared to this where the vertex crosses, kind of like this X. Corresponding angles are congruent. So this angle 1 and angle 5 are corresponding angles because they're in the same location, the upper right. They are congruent, which means their angle measures are equal. And the other corresponding angles I have in this picture are 2 and 6, 3 and 7, and 4 and 8. They are all in the same location in relationship to the transversal and the parallel lines. Okay, two more definitions of angles: same side interior angles and same side exterior angle. Same side refers to the transversal, and the interior and exterior refers to either inside or outside the parallel lines. So same side interior angles are angles that are on the same side of the transversal, either on the left side or the right side of the transversal, and in between, inside the parallel lines. And we just saw by Euclid's fifth, they have to be supplementary, which means 180 degrees. So these two angles here that are in orange, angle 3 and angle 8, are same side interior angles because they are on the same side of the transversal on the left side and inside the parallel lines. So the measure of angle 3 plus the measure of angle 8 is equal to 180 degrees. I also have these two angles. So measure of angle 2 plus the angle 5 is 180 degrees because they are on the other side, but they're also same side interior angles. Same side exterior angles are exactly very similar. They're on the same side of the transversal, but they're outside the parallel lines. They're also supplementary. So these in pink, angle 4 and angle 7, are on the same side of each other of the transversal, but outside the parallel lines. So the measure of angle 4 plus the measure of angle 7 is also 180 degrees. And I can say it's the same thing for 1 and 6. They're on the same side of each other, and they're outside the parallel lines. Okay, two more types of angles, alternate interior angles and alternate exterior angles. Alternate refers to that the angles are on the opposite sides of the transversal. And then interior and exterior refers to being in between or outside the parallel lines. So alternate interior angles are on opposite sides of the transversal. One has to be on the left side, one has to be on the right side, and they're both in between the parallel lines. So from this example, angle 2 and angle 8 in purple here are alternate interior angles. One's on the left, one's on the right, and they're inside the parallel lines. And what do we know about these? I use the abbreviation AIA. These alternate interior angles are congruent. So that means, in this case, angle 2 is congruent to angle 8. Or the measure of angle 2 is equal to the measure of angle 8. Do I have any other alternate interior angles from this picture? Yes. 3 and 5. 3 is on the left, 5 is on the right, and they are inside the parallel lines. Conversely, alternate exterior angles, which I abbreviate AEA, are angles that are on opposite sides of the transversal and outside the parallel lines. So that would be in purple here, angle 4 and angle 6. And again, the angles are congruent. That means angle 4 is congruent to angle 6, or the measure of angle 4 is equal to the measure of angle 6. And they're not the only alternate exterior angles. 1 and 7 are on opposite sides and outside the parallel lines. So they are also congruent. Okay, so here's a nice little summary page. Alternate interior angles, alternate exterior angles, and corresponding angles are all congruent to each other, while same side interior and same side exterior angles are all supplementary. Okay, I'm going to use this for the next page. I have a bunch of questions on the next page. Here's one way to look at this diagram. I have two parallel lines, A and B, and I have two transversals for those parallel lines, X and Y. That's one way to look at it. When they're parallel lines, that means a lot of things are going on. That angle 5 and angle 9 are corresponding, but they're also going to be congruent. But another way to look at it, I'm going to erase this. Another way to look at this diagram is just that X and Y are just plain old lines, and A and B are transversals. What does that mean? That means angle 5 and angle 1 are still corresponding because they're in the same location of each other. They're just not congruent any longer because X and Y are not parallel. Okay, I'm going to pause the video and I want you to do the next page and compare it to my answers. Okay, so here are all the responses, and sometimes they're congruent, sometimes they're supplementary, sometimes they're neither. So 9 and 16 are alternate exterior, but since X and Y are not parallel to each other, there's no relationship. And the same thing goes for 9 and 14. They are corresponding, but they're not congruent or none. because basically x and y are not parallel to each other. Again, here's another page for more practice, so I'm going to fill all this out, so you might want to pause the video, try it on your own, and then compare to my answers. Okay, so those two lines are parallel. I have my angles 1, 2, 3, 4, 5, 6, 7, 8, and I look at all these angles, and some of them are corresponding, alternate interior, exterior, same side interior, exterior. Those last two, when they're the same side, interior or exterior, they are supplementary. They add up to 180. So these two examples aren't too bad. This angle here and this angle here are corresponding. So 2x equals 86, so x equals 43 degrees, or 43. Now this one, I can't get to this one directly because there's no relationship, but I know that this and this has to be 78 because this is also corresponding. And then I have these two angles together make up a linear pair, and the linear pair have to add up to 180, so 3x plus 33 plus 78 equals 180 degrees. 3x plus 111 equals 180 degrees. 3x equals, subtract over the 111, equals 69. So x is equal to 23. So you had to go, couldn't go about this directly. You had to realize that 78 that was here was also here, and these two angles, because they make up a line, is a linear pair. Couple more examples. Well, because of these pink arrows, these are parallel lines, so these two angles are same side interior angles. That means they have to equal 180 degrees, so 80 plus x equals 180. X equals 100. That was pretty easy. And then these two angles here, again, because of this parallel line, these are our alternate interior angles, and they must be congruent, so y is equal to 70. That wasn't too bad. Now, when we see this picture, oh, guess what? We just have these two angles here are vertical. 8x plus 7 equals 9x minus 4. I can add the 4, subtract the 8x. I get 11 is equal to x. So that's 11. But then I have these two angles are also vertical. So 5y equals 7y minus 34. I'm going to subtract the 7y. Negative 2y equals negative 34. And I divide by negative 2. I get y equals 17. Okay? Vertical angles are congruent. Not everything is going to be between parallel lines. Now, the next few pages are examples. I'm just going to put up the answers for all of them. There's a video to watch with the top thrill dragster, and hope you enjoyed the video. Ask questions in class if you don't understand something. Thank you. So you need to click on this hyperlink to watch the video of the top thrill dragster, and then we're going to complete this page. I'm going to pause the video, and actually I'm going to just pause the video and do all the work without talking about it. So here are the results for this page. The measure of angle 2 is going to be congruent to the equal to the measure of angle 3 because they're alternate interior angles. And then the measure of angle 1 is 122.39 because it is a linear pair with angle 2. Okay, so here are the solutions to this page. You had to work with alternate interior angles and same side interior and so on and so forth. And finally, here's a work for this last page. I know it's a lot of work all together at once, but you know, I wrote out a lot of details. If you have any questions, please ask me during class. We are having a quiz and or we're having a test next week, but you need to know all these definitions and all how these angles are related, whether they're congruent, supplementary, so on and so forth. Okay, thank you for watching this video.